Hi, this is Mrs. Bajent, a math instructor for Cape Fear Community College and UNCW. Today's lesson is going to be on increasing and decreasing and piecewise defined functions. So a function is increasing on an interval if its graph rises from left to right. So in other words, as x increases, as x moves right, y also increases. Y gets higher. So as x moves to the right, y gets higher. A function is decreasing on an interval if its graph falls from left to right. So as x still moves to the right, we always move right. Right is always right. As x moves right, y gets lower or decreases. And a function is considered constant if it does not rise or fall from left to right. As x increases, y remains constant. So in other words, it's a straight line. So when stating intervals of increasing, decreasing, constant, always state the x interval to describe the behavior of y. So always state the x interval to describe the behavior of y. Never use brackets. Always use parentheses when stating these increasing, decreasing, or constant intervals. So, and use a horizontal x interval to describe the vertical behavior. So that's what we're saying here. State an x interval using the horizontal x interval to describe the vertical behavior of y. So, if you want to pause this and write these notes down, go ahead and do that. And then just pick back up and we'll move on to the next example. I'll give you a moment to pause and read over this. Take a screenshot of it. And I'm going to move on. It's just examples of the different graphs. From increasing, it's increasing from here to here, because see how it's getting higher? It's decreasing from here to here. So here we're decreasing, here we're increasing, and then here we're constant. So yellow we said was increasing. Orange is decreasing, and green was constant. Okay, so let's do an example together. Let's state the intervals where this function is increasing, decreasing, or constant. So we're going to state the intervals where this function is increasing, decreasing, or constant. When we state the interval, you will always use the x interval and always use parentheses. Okay, so for the increasing function, we are moving from left to right and going up. So we're going from left to right and we're going up. So there's an increasing interval. And you're using the x-axis. So from left to right, where does this start? It starts from negative infinity. And where does it stop increasing? It stops increasing here. And so what is the x-coordinate? It's negative 1/2. So an increasing interval is negative infinity to negative 1/2. Let's do that one more time so you can really absorb that. I didn't realize that would erase the whole graph. So we'll do this. Okay, so the graph started increasing from here to here. You see how the graph is getting higher. And so from left to right, it's starting with negative infinity, and it stopped increasing here. And the x-interval, or the x-coordinate there, is that negative 1/2. The 3 is the y-coordinate, and we're only using the x-axis. So the increasing interval is from negative infinity to negative 1/2. Do you see anywhere else on this graph where the graph is going up, where it's increasing? Yes, you do. It's right here. Look, it's increasing here. It's going from left to right. It's going from left to right and it's moving up. So where did it start to go up? Before that, it wasn't going up. But at x equals 5, it started to go up. So our new interval is from 5 to where? Where does the graph stop increasing? Never. It goes to infinity. So there are your two increasing intervals. Okay, do you see any decreasing intervals? Do you see anywhere where the graph is coming down? Yes, from here to here. So you just simply state the x coordinates of that interval. So where does it start to come down? It starts to come down at x equals negative 1/2. And where does it stop going down? 2, at x equals 2. Do you see anywhere else in the graph where the graph is coming down, where it's decreasing? So you're done. So let's move on to the constant. Do you see anywhere in the graph where it's a flat horizontal line, where the graph is constant? Yes, right here, this flat line. So what are the x coordinates of that portion of the graph? Yes, we have x is 2 here, and then it stops at x is 5 here. So there we have our increasing intervals, our decreasing intervals, and our constant interval. We use the x-axis to label our starting and finishing points in our intervals, and you always use parentheses. Now let's talk about relative extrema. The relative maximum or minimum is a y value. The relative maximum or minimum occurs at the x value. It occurs at the x value. So we will describe y using the x value. So the max is y at x. This is how we will state our answer. Whenever we are asked to describe the relative maximum or minimum, this is how you will state the answer. The max is whatever the y-coordinate is at x. Relative maximum or minimum is what it sounds like. It's the lowest point or the highest point in its relative area. So I'll give you a moment to screenshot this or pause it to take notes. And I'm going to move on. So let's look at this example here. Determine any relative extrema. We are given the function f of x equals the absolute value of x plus 2 minus 5. And we also want to identify the domain and range. Well, let's get out of here and graph it. Okay, so I have gone ahead and graphed this in my TI-84 Plus calculator, and I've taken a screenshot and provided it here for you. So we're looking at any relative extrema. So we're looking for the maximum or minimum point on this graph, and we will state it as the maximum occurs at the y-coordinate, at the x-coordinate. So we have the graph is given here, and let's look at this. The domain, what is the domain? Well, ask yourself the two questions. is x in the denominator of a fraction is x under an even radical? The answer is no to both of these questions. So your domain is automatically what? That's right, it's all real numbers. And the range, remember, you look at the graph and you try to determine what is the lowest point of your graph and what is the highest point of your graph. So here, our lowest point is given here. And what is that coordinate? It's -2, -5. So the lowest y-coordinate of this graph is at -5, and we do include that on the graph. You see it is included in the graph. There's no hole there. So we're going to use a bracket to show that our graph has a lowest point of -5. And does our graph ever stop increasing? No, it goes up forever and ever, so it goes to infinity. So in finding the range, we have also actually found the relative extrema. We have a minimum point here, a lowest point, and the lowest point occurs at -5. So the relative extrema is the max, the min, not the max, because it's the lowest point. So the minimum is the lowest point, which is -5, and it occurs at x, which is, what is the x coordinate for that ordered pair? -2. So the minimum is the y-coordinate, and it occurs at the x-coordinate. The minimum is the -5. That is the lowest point on your graph, and it occurs at -2, which is the x-coordinate. So the max, I'm sorry, I keep saying max. The minimum is this coordinate here, -5, and it occurs at -2.